Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called biLINEgual by Rai, and here are the rules. We have Quattro Quadri, I think that's what it's called, where we have four 3x3 boxes in the puzzle, and we need to fill each 3x3 box with the digits 1 through 9 so that no digit repeats in any row, column, or box. Or, as I can put it in the way that I phrase normal Sudoku rules, you have the digit in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. That's the reason why I use that designation or that explanation for normal Sudoku, even though, yeah, this is not normal Sudoku. But the thing is, that rule set applies to so many of the variants that you can actually easily just say that all the time for most of them. And yeah, that's the reason why I say that. Because you could just, it's basically the same rule set, even if it's Quattro Quadri, which is here, or if normal Sudoku. And you can add little variants by just tweaking a couple of little words, depending. But yeah, this is Quattro Quadri, but the rule sets are essentially the same because you can place the digits 1 through 9 in each. You must place the digit 1 digit from 1 through 9 in each cell, and you cannot have repeats in any row, column, or box. We also have bi-ratio lines, which are the bi-line in the biLINEgual part of this puzzle, where each bi-ratio line is split into exactly 2 segments by box borders, right? So this is split into 2 segments here, 2 segments here, 2 segments here, etc., etc. And the sums of the digits on each of the 2 segments are in a 1:2 ratio, which is why I guess why this is a bi-ratio line. I guess that works, yeah. Bi is usually is a prefix that means 2. So, pretty apt here. So anyways, though, you could have something like, say, 3 here and 6 here. And that would satisfy this biLINEgual line here. It obviously does not suffice for this one. And that we can probably get to some examples there. But anyways, that's since this is the sum of this segment and the sum of this segment is in a 1:2 ratio, that satisfies the bi-ratio line rule set. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so let's start with this. One of these is going to be double the other. But since there's another line including these 2 cells and a different cell, that means whichever one that's in a 1:2 ratio must then be in a 1:2 ratio with the other digit, or with the other sum, right? And so since if we try to have this be a 1:2 ratio with the smaller of the 1:2 ratio, like we did of 3 and 6, that's not going to work because 6 plus another digit is always going to be greater than a 1:2 ratio with 3. So it has to go the other way. So either this is 1 and that's 2. So does that work? If this is 1, that's 2. Then this must be in a 1:2 ratio with these sum. So that would be 2 and 4. So that would be 1, 2, 3. That works. 2 could work with 4 and 6? Yes. So then 2 is in a 1:2 ratio with 4. 4 is in a 1:2 ratio with 2 plus 6, which is 8. And then you could have 3, 6, or 9 here, right? And that's the extent of it. So 3 and 6 are in a 1 to 2 ratio. 6 is in 1 to 2 ratio with 3 plus 9, which is 12. So then we have something similar here, right? So this must be the smaller of the 1 to 2 ratio for this digit. Because, again, if it was the larger one, this smaller one would be in a 1 to 2 ratio with that digit, but it cannot be in a 1 to 2 ratio with even a larger a sum. So we could have 1, 2, but then this would have to be 1 plus 2 other digits adding up to 4, which is not possible. So that doesn't work. 2 and 4 could work. So we have this being 2, and that's 4. 4 is in a 1 to 2 ratio with 8, so this would have to be 1, 5 in that scenario. And then what about 3 and 6? You could have actually 4 and 8 also. Huh. This is getting a little bit more. 3 and 6 means these two must add, so 6 is in a 1 to 2 ratio with 12. So that means this must add up to 9. So no 3, no 6. You could have 3, 1, 8, 3, 2, 7, or 3, 4, 5. So that's pretty broad. This is 4 digits, right? Yeah, this is 4 digits. This is in 1 to 2 ratio. This cannot be, obviously, the larger, because that's a single digit, and that's not going to be equal to, it's not going to be, 4 digits can't add up, they add up to at least a 2-digit number, which is going to be greater than that, a single digit, right? So this must be the 2 in the 1 to 2 ratio. And this has to be a 1. So this has to be 5 through 9. Same with this scenario. This is 3 digits, which is going to add up to at minimum 6. If you try to get that be the smaller part of the 1 to 2 ratio, this would have to be 12. So this has to be, then this must be 6, adding up to 6 or 8. Interesting. So therefore, this is guaranteed to have a 1. It's either 1, 2, 3 or 1, 2, 5 or 1, 3, 4. And this has to be in a 1 to 2 ratio with that. So if this is 1, 2, 3, this must be a 3. If this is 1, 2, 5 or 1, 3, 4, then this is 4. So this is in a 1 to 4 ratio, or sorry, 1 to 2 ratio. It could be 10. So we did this. What about 4? 4 and 8 work. So 8 would be, 1 to 2 ratio with 16. So yeah, we don't, this is very large. So this could be 4, this could be 8. So those are also possible. Hmm. 4 and 8 would mean that the other 2 remaining digits add up to 16 minus 4, which is 12. So it could be 3, 9, or 5, 7. So again, if this is 2, that's 4. This would be 1, 5. If this is 3 and 6, you could have 1, 8, 2, 7, or 4, 5. And if it's 4 and 8, it's either 3, 9, or it's 5, 7. So we can't have a 6 there, which doesn't really help too much. Hmm. Oh. So these two digits. Huh. What are so you could have 3 here, which would then make that a 6 here. You could have 4, which would make that 2 or 8 here. You could have 5 here, which would make that 10, which doesn't work, or 2.5, which doesn't work. So you can't have what would be the scenarios? Yeah, there aren't many. It's basically 1, 4, and 3. Let's go. Okay, let's go through the scenarios here. You have 3 here, 1, 2. You can't have 3 here. Okay, so that's one issue. So if this is 3, this is 1, 2, 1, 2, and that's 3. You cannot have 2, 3 here because that's 5, and that's not going to be in a 1 to 2 ratio with any single digit. So it would have to be 1 and 3, and then this would be 2 or 8 in that scenario. So that is one possibility. If you have 4 here, this would be 1, 2, 5 or 1, 3, 4. So again, you could have 4 here, but you cannot have 1 there in that scenario because 1 and 4, you can't have 3 and 4 in that scenario either. Because 3 and 4 is, if you have that, you get 3.5, because 3 and 4 is 7. And if you double 7, you get 14. So that doesn't work either. So if this is 4, this is 1, 2, and 5 then. You could have 2 here, 1, 5, 1, 5, and then that would be 3. You could have 1, 2, and 1, 2, and this be 5, and that would have to be 6. So those are all the scenarios, I believe. So we're guaranteed this is 1 and 2, because we cannot find a 1, 3, 4 that works. 4 would have to be here. This would be 4. You would have 1 or 3 there. These would then add up to 5 or 7, which you cannot double to be a single digit or have to be a single digit. So if you have 1, 2, 5, you'd either have to have 1, 2 here, 3, which makes that 6, or 1, 5 here. 2, 5 doesn't work because that's 7. So 1 cannot be here. Okay. So this is always going to be in a 3 to 1 ratio here. Does that tell us anything? I don't really know. It is divisible by 4. I mean, that's all we really know there. This cannot have 1 and 2 as a sum. So this is at minimum 3 and 4, which is 7. So this has to be the high. Okay, so yeah, I should be labeling these as higher and lowers, I guess. This is low, this must be mid, and this must be high. This is low, that's mid here. This is obviously the low part of this. This doesn't have to be. This has to be the lower part of this. Right? Because this is at minimum 3 and 4. The only way you could have this be 8 would be if this is 4, but this can't be 4 because 4 in a 1 to 2 ratio with 4 digits would not work. So this must be the higher one of these two. This is also the lower one of these 4, obviously. You cannot have 9 here. That would force 18 there. So this cannot be 9. If you have 8, it's 7, 9. Okay, so if you have 5, it has to be either 3, 7, or 4, 6. If you have 6, it could be... yeah, so this is 3 through... what are the possibilities, I guess? 3, 7, 4, 6, and that's 5. 6 would require 3, 9, 4, 8, or 5, 7. Yep, so any of those could work. 7 would require 5, 9, or 6, 8. 8 would require 7, 9 here. Okay. 5 doubled is 10, so this would have to be 1, 2, 3, 4. So it'd be 1, 3, that's 2, 4 there. These are in a 1 to 2 ratio. We know the remaining digits in box 1 are 3 through 9. These are in a 1 to 2 ratio with another digit, so there's no 5, 7, or 9 here. So 3 could be with 6 here, 4 could be with 2 or 8, 6 could be with 3, and 8 has to be with 4. So those are the possibilities there. Oh, interesting. These two are in a 1 to 2 ratio with a single digit, and they're also in another 1 to 2 ratio with another digit. I think it then has to be... how does that work? 2 digits are in a 1 to 2 ratio with one digit, and then in a 1 to 2 ratio with another digit. But, so they have to have a 1 to 4 ratio, but 2 can't be here. Huh. Maybe this does have to be 1, 3, 4 then. Oh wait, this doesn't have to... what am I thinking? Okay, yeah, that's all off. This doesn't have to be 1. So that's the problem there. Okay. Never mind. 3 digits can be double any digit here. It doesn't have to be 3 or 4 only. So that was not correct. I don't know what I was thinking. Yeah, I was thinking old region sum lines things. This is the interesting part. It's in this sum is in a 1 to 2 ratio with 2 digits, and they're unique. So therefore, the only possible that means those digits are in a 1 to 4 ratio. Well, 2 digits can never add up to 2, so it can't be 2 with 1 and 4, so this has to be a 2-8 pair. So this is 2 and 8, which does force this to be 5. And this must add up to 4 here, so this must be 1 and 3. Well, 1 is only in a 1 to 2 ratio with 2, so this can't be 2 because of 2-8 pair in the box, so this must be 3, and this must be 1, which makes this 3 is in a 1 to 2 ratio with 6. Yeah, this doesn't have... I was using old region sum line intuitions there. That was bad. Okay. So this is 2 and 8. This is 5. 5 is in a 1 to 2 ratio with 10 at most. So this must be 10 here, which means this is 1. This is 3. This is 2, 4 as a pair. That makes this 2. So 1 and 2 are a 1 to 2 ratio. 2 in 1 plus 3 is in a 1 to 2 ratio. This 2, 4 pair limits 2, 4 in the rest of the box. So this cannot be 4. This can't be 2. There's no 1, 2, or 3 there. That's interesting. No 3 here because of 3 in the box, so this is 4, which is in a 1 to 2 ratio with 8, which means this is adding 8 is in a 1 to 2 ratio with 16. 16 minus 4 is 12, but we can't have 3, 9, or 4, 8 here, so this is 5, 7 as a pair. Remaining digits in this box then are 6, 8, and 9. 6 cannot be here, so this must be 6 here. And we have 8 and 9 left. So these two must be in a 1 to 2 ratio with these two. Well, most you can have is 15, but that's not going to be in a 1 to 2 ratio. You have to have 30 on the other end to be in a 1 to 2 ratio. So it cannot be 6 and 9. It must be 6 and 8. 14, and that means this is 7, because it can't be 28, so that's 6 and 1. Remaining digits in box 4, we have 5, 6, 7, 9. 6 and 9 cannot be here. 5 and 7 cannot be here. So this must be 6, 9 as a pair, which eliminates 6, 9 in the rest of the box. So this is 5, 7 as a pair. So this is 12. 2 digits are not going to add up to 24, so this must add up to 6. So we have either 1, 5 or 2, 4. This can't be 5. This can't be 1, 5 because of 5 in the box, so it's 2, 4 as a pair. Remaining digits in box 1. We have 3, 4, 5, 7, 9. So no 4s here, no 9 there. Okay. So this must be in a 1 to 2 ratio with that digit. You could have 3, 4, 5, so this could be 6, 7, or 9. Remaining digits in box 2. We have 1, 3, 6, 7, 8, 9. No 1, 8 here because of 1, 8 in the column. No 8 here because of no 8 or 6 here because of 6 or 8 in the column. 2, 8 as a pair eliminates 2 here. So this is 4, that's 2. So 2 and 4 is in a 1 to 2, eliminates 2 here. So this is 4, which makes that 2. This can't be 3 because of 3 in the column. This is not going to add up to 2, so this must add up to 8. And it has to be 1 and 7, because we can't have 2, 6, or 3, 5 because of 2 or 5 in the box. So this is 1, that's 7. Which eliminates 7 in the rest of the row, and 1 and 7 in the rest of the box. So this is either 6 or 9. If this is 6, this adds up to 12. If this is 9, this adds up to 18. Okay. 3 eliminates 3 from being there. 2 eliminates 2 here, so this is 8 and 2. How does this work? Okay, so 4. 5 would make this 4 and 6. So this can never be 3 here. 5 would mean this is 10. 7 would mean this is 14, and it cannot add up to 14. So this is 5, this is 7, this is 4 and 6, which makes this 9, which makes that 6. There's no more 6 here. This is 9. No, this cannot be 3, 6, or 9. It's 8, which makes that a 3. Therefore, this is no 3 here. There's no 9 here. This is 4, 5, 7 as a triplet, which eliminates 4, 5, 7 in the rest of the box. This can't be 4, 5. It's 9. And that makes this 3. 7 and is 1 to 2 ratio with 14, so this must be 5 here, which means none of these are 5. 9 means this adds up to 18, which has to be 4, 5, and 9, so this is 4. That's 7, which eliminates 7 here, so it's 5 and 7 there. And that's the solution. Apologies for this earlier part. I'm so used to region sum lines that I saw that and I was like, oh, this has to add up to a single digit here. And it's like, no, doesn't have to. And I realized that with this scenario here, which was good, I guess. But I should have saw this one first. Maybe. Um, yeah, not too bad. Yeah, it really, I have some habits there, I guess, from reading some lines. So that's not, that's obviously one thing I need to take a look into to make sure that I don't fall into that habit again. Fortunately, we were able to figure out pretty quickly that that couldn't be the case. I mean, there could be other possibilities there. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.